Hello, my name is Rodrigo Garcia. I work with Expressive in the Arduino team. So let's start the presentation. Today, we will talk about Arduino and beyond. So as an overview, we'll start talking about Arduino. Then we will talk about how ESP32 Arduino is structured. Later on, we will talk about libBuilder. And then finally, we will close with the Arduino's component topic. As an overview, I can say that Arduino was created in 2005 in the university in Italy, in the Institute of Design. And this project was made for non-programmer people. So basically people who deal with art, maybe design, and they wanted to use physical computing at the time. But they were not programmers, so they had no idea how to do that, how to deal with hardware, software. And the project was targeted for these people. But it started earlier in 2003 with a master project from Hernando Barragan from Colombia. And he created the wire project, which is today the same structure used by Arduino. At the time, this project had seen few targets. So it should have an IDE for any operating system, Windows, Linux, or Mac OS. And this integrated environment should be easy to learn the language, very simple framework. Everything should be integrated to that. So it means that the tool chain should be transparent to the user. The user should not deal with any detail of creating the application, including the bootloader. And it has a monitor, a serial monitor, in order to debug basically the software and help the users to understand what is going on when they're creating their projects. Of course, it has a very high abstraction level. It has a lot of libraries and examples, which is part of the program as well. So the idea is to create a community at the time. And this project was so good and well received by the community that it is very strong today, and a lot of different manufacturers of MCUs decided to support it, creating their own frameworks for Arduino. So what is basically Arduino? Arduino is composed by software and hardware. In our case, the hardware are the ESP32 boards, and the software is basically an API implementation. We can see a lot of details about this language and this API in the website of Arduino, which is the Arduino CC. It is based on C, C++, has a lot of classes and functions, and those are basically used for dealing with characters, strings, bit, bytes, math, random. In the case of the MCU, we can control GPIO with digital reading and writing for analog ports as well, using PWM, for instance, the tone, which is creating sounds in different frequencies, use PWM, and it is a sort of analog writing. We can measure time. We can also monitor GPIOs if the signal is raising or not, or so we can create ISRs based on GPIOs and have a sort of let's say callbacks, or in the case ISRs for GPIO change of signal. There are also some basic support for keyboard and mouse. And of course, it has a lot of APIs to talk to different external hardware, sensors, maybe some TFTs based on SPI or I2C, which is called wire in the case of Arduino, serial ports, and there is an abstraction called Stream API, which connects everything together, meaning that, for instance, if I want to read a string from a UART port, I can use a Stream API to make the data coming from the UART going to a string or any kind of other data, reading specific data types. So what is ESP32 Arduino structure regarding the Arduino project? Today, we have two main versions. One is the version 10X. Today, the latest one is 106. It is based on IDF 3.3. And the problem with that, or let's say not the problem, but the way it was done, is that it has a lot of code in the API for Arduino based on register manipulation. So imagine that today we have different SoCs. So we have the ESP32, S2, S3, C3, and we had to support that based on that code. We would need to write a lot of code, a lot of testing, and it would be very time consuming. So in the version 2.06, which today is the 2.04, it is based on IDF, which means IDF for form. And everything was, all the Arduino API actually layer was refactored to use IDF drivers. So as IDF moves on and supports more and more SoCs, Arduino does the same in a very easy and fast way using IDF as base. In addition to the regular Arduino API, ESP32 also supports ADC, DAC, LED-C, RMT, touch, Sigma Delta timers, PSRAM, USB, CDC, and MSC. Also, we have a number of libraries that support in the framework, I2S, SD cards, Ethernet, Wi-Fi, Bluetooth, Classic and BLE, OTA, file systems, different ones, protocols, HTTP, clients and servers, MDNS, DNS service itself for IP addressing, and Rainmaker, which is a project from Arduino, from ESP, from Espressif. Well, we support different SoCs. So today in the version 1.06, we only support ESP32. For the other 2.04, we support ESP32, the S2, C3, and S3 as well. And the layers are like that. So we have the MCU in the lower layer, of course, and then we have FreeRTOS that can be used, and it is used by IDF basically. So, but it can be used any place in the software. We have the ESP-IDF and HAL talking to the MCU itself. And the Arduino layer is split into two different layers, an upper and lower one. The lower one talks to the HAL level and IDF as well. And the upper one is the Arduino API itself, which is used by the Arduino sketches and Arduino libraries as well. So the sketches can use libraries, and the libraries use the Arduino API as well as the sketches in Arduino. So this is basically what it is. Although, for instance, it is possible to create an Arduino sketch, and it might be basically purely written using IDF, which is very interesting, by the way, because IDF is integrated in Arduino, as I said. We will see that later on, how it is done. So we can build an application using Arduino using basically two methods. One is using the IDE, and then we have Arduino IDE and the VS Code with Platform IO. And also we can use Arduino's component in IDF, basically. So in the case of Arduino with an IDE, we can install packages, and one of the boards of the packages is ESP32. So let me show you how it is done. So this is the IDE from Arduino, basically. So we have a basic program. This is the wire, as I said, which has this implementation of a setup, which is run once, and loop is run every time in the loop, of course. And then we have in tools, the board manager that allows us to add boards. And we can add ESP Arduino, which is, in this case, is the one official, the latest release, which is 2.04. And I have here this in a sketchbook Arduino. And this sketchbook is very interesting because I can add a board in my sketchbook, which is a list of sketches and programs from Arduino. And this board actually might be, for instance, the latest version from the GitHub of Arduino for ESP32. This first one is only the official installed version, in the case 2.04. And I have different boards here. So you can see that we have S3, C3, S2, and the regular ESP32, along with other manufacturers from different places. I can set up everything here in terms of frequencies, modes, and if I want debug messages, PSRAM, and so on. In the case of Platform I/O, I use VS Code as base. So I have Platform I/O here. I can basically create programs, new projects, and they will be built using VS Code. So it's very similar to the IDE. It's a different way, of course, and it has its own way of setting up and installing. But the idea is the same. I use that to create, compile, build, and then link, and then upload any program done with Arduino to the hardware. So we can use the IDE to test and develop Arduino using the latest master branch from Arduino GitHub, using this board in the sketchbook, as you saw demonstrated in the IDE itself. It's not possible to be done with the platform I/O, but only with the Arduino IDE. More information can be found in this URL. Let's see this URL really quickly. So here you see how to install the IDE and everything. There are instructions about it. It uses the IDE in Unix as example. There is also information about Platform I/O and how to build it, and how to install the GitHub version in the board in the sketchbook, basically here. There is all the information. We need to run this get. We will install the chain chain, basically. And then we can run it in the sketchbook. That's basically it. So any doubt, you can go to this URL and follow the instructions. So let's talk about Arduino libBuilder. What is the point about libBuilder? Why we need that? Basically because the GitHub in Arduino, it has many scripts for building the final releases, for running CI, even for updating IDF in the GitHub and creating new releases and versions upon the new releases of IDF itself. So as I said, today everything is based on IDF 4.4. This is a very important point because there is no way to run the Arduino core based on other versions of IDF. Only on the IDF 4.4 we can use 4.40, 4.41, and 4.42 today. Everything is compiled in the, let's say, in the IDE or any other place using the compilers for the framework in the API level. But it has IDF as well. So where the IDF enters in the process, IDF is precompiled into static libraries, and those libraries are part of the package of installation for Arduino. So the installation package has the libraries precompiled, also has all the header files for these IDF interfaces. So when we write any Arduino code and it is compiled, when it calls any IDF function, this IDF will be compiled against the header files and then linked against the static libraries. It means that we cannot change IDF in the Arduino framework. And this is why we have Arduino libBuilder, which will, of course, build every static library based on a certain version of IDF. So this is why we have it. It builds all the IDF components and also some external libraries for each one of the ESP32 SoCs. So for the S2, S3, and C3. And what are the external libraries in this case? We have Rainmaker. We have, for instance, any image recognition, speech recognition. Any kind of IDF project can be built and also added to the process with libBuilder. So it's not just about IDF components, but also about any project from IDF as well. So basically, it's what I said. It has all the static precompiled libraries. And then we can see that in the GitHub. There is a GitHub for that. And I will show you this GitHub and how it works, basically. So this is the Arduino libBuilder GitHub. We have here the files and some instruction. It's very basic. We need to pre-install all the tools we need in Linux. It's done with Linux, basically. There is no way to use, or maybe Mac OS as well, of course, but no Windows support at this time. So we clone it, and we run build shell, the script. And this script has some different options. As we can see here in the script, we have these options. And what we do is when we install it, we basically build everything. We build for all the SOCs, we build all the libraries and everything that is needed. Everything is listed in different descriptors that are in this GitHub. And we can do certain phases or pieces of it. For instance, we can just compile, we can build it, we can install it directly in our Arduino space. We can define targets. For instance, we only want to build for the S3 or the C3. We can deploy it directly. We have different options here in this script, and we can do whatever we need. So let me show you how it is done in Windows. In the case, there is a way, and this way is basically using Ubuntu in the WSL of Windows. So here we have the structure in libBuilder. I just cloned the GitHub here, and I started building some stuff using the build script here. So when the build script runs, it downloads components. So if I go to components and list it, components, we'll see the different components here: Rainmaker, speech recognition, camera, LittleFS, graphics, and so on, including Arduino as a component here. So it is a sort of application, by the way. Everything is built, and we see the results in the out folder. So now we have this structure, and this is what has been created by libBuilder. And if we go to the SDK, we'll see ESP32, because I didn't build it for the other SoCs, but we'll have everything listed here, which is very similar to the structure we have in the Arduino installation itself. So this is replaced directly in the Arduino installation, and we have everything there. You'll see I'll show that in the folder here. So this is the folder installation for Arduino. Basically, what libBuilder will do, will create this space here for SDK. And we have here all the different chips. And each chip will have its own SDK config, and the libraries will be right here. You see all the precompiled libraries here. This is done by libBuilder. Everything here, all the components and all the different projects such as speech recognition and so on. Everything here. And then if we go to the include, we'll see everything related to the components of IDF, which is included in the Arduino project itself. It's pretty easy, straightforward. So libBuilder is used to build Arduino itself, all the project, and the layers for IDF here, which are precompiled, as I said. So as I said, libBuilder is used to build libraries, static libraries, and create the layer and the package of installation for Arduino, ESP32 Arduino, basically. So who uses that? Us, developers of the project, and also some developers of a specific project, such as Rainmaker. They need to test that against Arduino, so they use libBuilder for that. It is one way of testing and making sure that all the project will be correctly created based on libBuilder, and will run correctly with the package of installation for ESP32 Arduino. But there is another way, and this way is basically Arduino's component, in the case using IDF44. So one interesting thing about the GitHub for Arduino in ESP32 is that it is already configured to be an IDF component. So it has all the necessary files, such as the CMake list and also the kconfig file in order to use makeconfig, the config menu actually. So it is a native IDF component of IDF project. It is very easy to be used. So we can find more information how to install it here. But I have created a different way of doing that, and I will describe it and demonstrate it in a few minutes. So let's see this website. So this is the website for installing Arduino's component here. And basically has some instructions. I will present a different way of doing that, maybe a faster way and with less errors. And when we do that, we can create in the component in our project directly a sketch like that, for instance, which basically just prints loop every second and run it in IDF directly. It's very interesting. I'll show you how to do that. And that's a very good way because I can again change IDF setup here, also modify my application, my version of Arduino if I want to. I can just go directly to the different layers of Arduino API and change it the way I want. Create literally my own Arduino. It is very, 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 very interesting. Let me show you how. So I will talk about how to create this Arduino's component in a few steps. First, we need to install IDF44, any version of it. The 204 version Arduino core uses IDF441, and I will show you which commit is used for that. We then create a project. We can just copy, for instance, IDF example from the get started like hello world to that project and modify it from that version. It's pretty easy to do that. Inside the project, our project, we create a folder called components. And then we go to that folder. We clone GitHub as folder Arduino there. And basically, we will then use it there. Then we will have our project component Arduino from GitHub. Then we go to the Arduino. We check out the desired Arduino core commit. In the case of 204 Arduino core, we check out the branch C93BF11, and I will show how to see that, how to find that information. And then we can just copy the SDK config from Arduino for our specific target SoC in the project folder, which makes everything easier because with that we can use Wi-Fi, Bluetooth, everything there. We don't need to go in the menu config and configure one by one. We just go directly that and use the full SDK config from Arduino. We also copy the main CPP project from Arduino to the project main folder, which will be executed by IDF. And then we change CMake list in the project to include the files we use in our project. We go to the menu config and turn on auto start Arduino setup and loop boot to make it run directly as an Arduino application. And finally, we build the IDF project using IDF PY. So, and then we will upload it to the hardware and run it and see the monitor most probably see run. Let me demonstrate to you how to do that. Okay, so I have here my IDF applications. So I'll create some folder, and what I have here is Windows. So what I have here is just Arduino. I just have cloned Arduino here to make it faster. So using this command and making it more easy to be used. So I'm gonna create a project. So let's say it is Arduino demo. So I go to that. So we create the project here, and we start with that, and we will copy an IDF example directly here to make it faster. Let me show you how. So I go to the IDF installation, go to examples, I go to get started, as I said, then we take the hello world, copy that, and then we copy that directly to the IDF applications. Let's get the content of it. So this is the example. It's a pure IDF example. I go to my project and copy that right here. So I have everything done here. You see that we have a main with the program. In this program, basically, is just a basic IDF application that keeps a countdown. Oops. Makes a countdown and restarts ESP. That's what it does. But we will just replace it. So let's show how to do that. So once I'm here, what I'm gonna do, I will copy the Arduino to here. So as I said, I need to create the components folder. And then in the components folder, I will copy the Arduino. I should clone that, but I will just copy that, it will be faster. So I go here, take this, and just move it inside components. Right? So it's like, if we move to components, it's like we have Arduino cloned here. We go to Arduino. And then if we see it, it has everything regarding the Arduino project from GitHub. So whatever you do, basically, if I go with Git status, I will see that it has already its status there, and I can check out a version. So I'll go and check out, as I said, the version for the Arduino Core 204, which is the one I will paste here. So check out the version. This is the version, the branch, and also the commit for this specific version. It is important sometimes, but in our case for 204, it is important because GitHub for Arduinos is way forward, so we need to use the latest version to make everything sure that everything is rightly done. So I just go and check out that version, which is the 204. And how did I get that version, this number here, this commit? Well, I got it from GitHub itself, from the release GitHub. So let me show you that. So as I said, where do I see which commit I should use for Arduino GitHub? So I go to releases in the GitHub, and then I see the C3BF11 here, and this is the commit that created the version 204. So that's why I check out this specific commit. So I have everything in sync. I have the code for Arduino API layer, and also IDF, and also the right commit here. So everything is correctly set up. So right after that, what I have here is the right component. And what I need to do basically is get the main app done and installed, which will be run by IDF. And also I need the SDK config as well. So what I'm gonna do, I'm gonna copy everything there. So I'm gonna go to tools, then I go to SDK, and I see the different SOCs here, and I will demonstrate how to do that, how to create using ESP32 and ESP32C3. So let's go to ESP32. When I go here, I see SDK config, so I'm gonna copy SDK config to my main project. Oops, I need to use the other bar. So 1, 2, 3, 4, 5. 2, 3, 4, 5, yes. And I will copy that with the name SDK config.esp32. Then I'll do the same for the C3. And I will call it C3. Then I will copy the main application from IDF, because Arduino is based on IDF and it has the app main there too. So I'll copy that to the project as well. I go to course and I go to ESP32. Here is the Arduino layer itself. So here I will copy the main CPP file from Arduino, the project itself. So go to course, Arduino, components, the project, and then I should have a folder main. So I'm copying basically to the main project path. So if I go back, now I am in the project folder, and I see they have these two SDK configs. So I will start with the ESP32. So I just copy the SDK config, ESP32 as SDK config, which will be used for this project. And another thing I can do, I can just go and change the name of the project. So for that, I change CMake list. And I edit that. Let me show you real quick. I can change the name here and change it maybe for anything, for Arduino test, for instance, or anything like that. So just go ahead and save it. That will be the name of the project and the binary as well, binary file. Then I go to the main source code. If I see it, I will see the hello world, which I will just delete because we will not use it. We will use the main CPP file basically. And then here, what I want to do is to edit the make file. But before that, if we look into the main CPP, as I said, it starts Arduino and runs setup and loop. So we need to create some source code for the sketch itself, which has the setup and loop code. So what we're gonna do, I will just go ahead and create this program, which is basically, for instance, sketch CPP, and I will edit that. Yes, I will create a new one. Then I will just start including Arduino, which is important in this case. Otherwise, it doesn't know how to find all the header files. Then I just go here and do a setup, create the functions for wire, which is used by Arduino. And basically what I do is to start the serial port Wait that to start. And then I finally do nothing else. I just do that. And I go to the loop, which is very basic loop. And what I will do is just use the serial, the UART in this case, print something. Loop. And hold for instance, 2 seconds. So we'll see something that will just write loop, 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 loop every time. That's what this sketch will do. It's very basic. It's just an example. So I just save it, keep it here in case we have any error here. So as we see it here, we have two basically files. So I need to edit CMake to include those two, the main CPP and the sketch CPP. So I go and on and ahead and basically edit the CMake file, CMake list. And here we had hello world. So now we're gonna have the main CPP and also sketch CPP. Build using those two source files. Save it. And then we just close it. So here we are done. We will go to the main folder. We list it. We have the SDK config. So we can go ahead and we execute IDF menu config. So we can set up it to run Arduino here. And I will just show you how. Take some time. I will display the menu right away. So now we are in the SDK config. We can see that we have the configuration for Arduino here. So if I enter that, what I need to do basically, I need to auto start Arduino setup and loop, which is set up here. I can change different setups for the Arduino itself. I don't used to do that, but this is how we do it. So we will need to make sure that the auto start Arduino setup and loop on boot is on. And then if we need to change anything and we want to change anything on the components, we can go here and do everything. We can see that Bluetooth, for instance, is on, Wi-Fi and everything else that Arduino used to have. So I go ahead and save it. And then I quit. And then I go and build it. And flash it to the ESP32. So I'm going to use an ESP32 board here. I will connect it. So I have it right here, as you can see, running. And I will flash it. So I flash. And then I need to set up the port. So the port will be COM3. Flash it and run the monitor to see the results. So we should see loop, 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 loop. It will take a while. So I will come back as soon as it is already compiled and flashed to be faster. Usually it basically, what it does is compile the bootloader first, which is being done right now. We can change all the setup for the bootloader in the IDF menu config if necessary. We'll finish the bootloader. We'll issue a message for that as part of the IDF building process. So we wait a little bit more. Then it will start building basically the IDF components. That's is done also in the process. Then after that, it will start basically, which is now doing all the IDF, we'll start basically creating, building the Arduino layer as well. So we'll compile the Arduino as component here. And when everything is compiled, we should see the final results because they will flash it and we'll we'll run it and display the monitor and serial port results here. We might see some warnings along the process, which is okay. Don't worry about it. There is no big deal. So once we compile it and we change only the sketch itself and we change the Arduino software we have and we are creating, and the build process, it will not compile the bootloader or the IDF layer again. So it will be faster. We'll see that it is possible to be done. And we'll see that it works fine, very fast. So I will show you also how we can do it for the C3 as well. So if we want to use the C3, all we need to do is to change the SDK config file and use the C3 version for that. We need to clean the whole build folder as first, of course, otherwise it will issue some errors there. So as you can see, there are some warnings. Don't worry about it. Again, these warnings are from the IDF components for now. Soon we'll see a lot of warnings from Arduino layer as well. Now it's basically compiling all the libraries from Arduino, ESP32 libraries, Arduino libraries. And then we should very quickly get to the end of the process. Okay, it's uploading the sketch, and we'll see very fast it running. As you can see, every 2 seconds, it prints loop, which is exactly the sketch we created before. So it's running as Arduino as a component in IDF, as you can see. Everything is fine. We can stop it. And then I will demonstrate to you that we can just change it. So if I go to the sketch itself, I can change it here to anything and rebuild it and re-upload it again. So let me show you a Wi-Fi example, very real quick here. So where are the examples? The examples are in 2 places, basically. I can go to the here to the in the code. I go to libraries. Then, for instance, for Wi-Fi, I look for the Wi-Fi library here in the GitHub. Inside the library, I have examples, and I can pick an example here. So I'm gonna pick the scan example. And I go to the sketch, which is this file. And this is a pure, let's say, Arduino code. And then I just go here and copy it. Then I go to the notepad. And I overwrite it with the example from for Wi-Fi. Save it. Then if I go to the, again, to the project, I can just issue the same command. It will build it again, it will be faster because it will build just the Arduino portion of it. So it has already compiled IDF, all the bootloaders, everything is sort of already done. So it should be very fast. At least I hope so. Yes, it is fast. It's already uploading. And we'll run the same sketch we just changed. You will see that sketch running here and scanning my Wi-Fi, showing the networks around me. SSIDs basically. So those are the SSID around me. So you see that Wi-Fi is working here and scanning Wi-Fi, showing all the networks here in the region. I can just stop it. Let's say I want to change it to because I'm running, as I said, on the ESP32, right? So I want to run it in the C3. What I need to do? I just change the chip. I go to the C3. Now, connect it. Will be a new conf file. Now it's the C3 here now. So what I need to do is just change the SDK config. So what I do is just go to the and copy the SDK config. So I copy SDK config ESP32 SC3 to SDK config, and we are done. That's all I need to do. It's copied. It's now C3, and I need to run IDF PY and clean it up. So I go for a full clean, because otherwise it will tell me that I'm in the wrong target. So I clean it, and I run it again, of course, in a different port, because we changed the board, so now it's COM4. It will take again some while to compile everything again and upload it, and you'll see that running on C3, and then I will change the sketch and we will finish the demonstration. So I'm gonna cut and we go to the end real quick, because it takes a couple minutes to compile and build it and etc. Okay, so it's uploading the software to the C3, and we'll see that scanning Wi-Fi in the C3 now with the same sketch, just changing the SDK config. We changed the target as well, which is really very fast and easy to do. So you see it's running already and displaying the Wi-Fi here. So guys, this is basically it. The last change we're gonna do, I will show you another demonstration for the C3, which will run the RGB LED here, new LED for the C3, and it will blink. And the target here again will be the C3. So let me show you that. So we go again to the libraries in ESP32. We go to the ESP32. Then we go to examples again. And we go to the RMT example. We have the new pixel example, which basically is an example that suppose that we have a number of new pixels in sequence, a total of 32 new pixels, and that will basically blink one by one, moving the light from the first to the last LED. So in our case, we just have one LED, so the final result will be that LED will blink. So you will see that, and this is the sketch for Arduino to use RMT. So we have the functions here, RMT write, and the setup, and so on. Here, set clock, init, and so on, to use RMT and ESP32. So we'll copy that and paste it again in the same sketch file. So here we had the Wi-Fi. We'll delete it, and we'll replace it with the RMT sketch, basically. We save it again. And then we rebuild it and re-upload it using the IDF. So we do the same command for the COM4, which is the C3 port. And you will see that it will be very fast again, because it doesn't need to build IDF again. It's just the sketch. So it's already uploaded it, and it will run, and it will see that blinking here. You see? So it blinks the LED, and that was very easy and fast, as you can see. And this is the end of our demonstration. I hope that you have enjoyed the presentation. We should move now to the Q&A session. So guys, if you have any questions, I'm here to help. Please go ahead, make your questions, and I will answer them. Thank you.
Hello, Rodrigo.
Hello.
Perfect. So we can hear you. So we can just start with the first question.
Mm-hmm.
What is the ESP32 Arduino's versioning scheme, semantic versioning, and what is the relation between IDF and Arduino versions? For example, is there an Arduino release for every IDF release?
So starting by the last question, no, there is no Arduino release for every IDF release version. Basically, as I said in the presentation, we have two, let's say, families of Arduino cores. One is the 10X, and this one is based on IDF3. And then we have also the current Arduino core, which is 20X. Today is 205 at this time. Different from what I said in the presentation. The presentation was 204, so everything is evolving very fast. And the version 205 is based on IDF44. We are currently working to support also IDF5. So you can expect maybe something by the beginning of next year for IDF5. And this new version will be there. And most probably going to move to a new release version for the Arduino core. It might be like 3.0 something, for instance. So there is no relationship between versioning schemes from Arduino to IDF.
Okay, perfect. The next question. Is ESP-IDF environment more fast than Arduino environment at the runtime?
Not actually, because both are compiled. At the end, everything is quite the same. The only difference is that Arduino is just a kind of a layer, let's say a software layer on top of IDF. So it's in the final or the end of the process, an Arduino Sketch is actually an IDF application, let's say somehow. So they're all together, and the performance will be exactly the same.
Okay, thank you. Let's jump to another one. If Arduino wants to enable a particular IDF config option, but the underlying IDF is precompiled, what are some of the ways users can enable that config option?
Okay, there are two ways, as I said, to build an Arduino application. One is using the IDE itself, and in the case of IDE or even with Platform I/O, you will rely on a precompiled IDF libraries. So when we think that we are installing Platform I/O or we are installing, for instance, the IDE, and we decide which core we want to use from Arduino, it will upload a package. In this package, will have IDF libraries precompiled. So when using those IDEs, there is no way to change that. But if you use Arduino's component, yes, you can do whatever you want, actually, because you can try to run it, although, as I said, there is this linkage between Arduino version and the IDF that's being used. So you need to keep the same version somehow, but you can change some stuff, for instance, for menu config or anything like that. You can change maybe some IDF configuration on that and build your own, let's say, configuration. So there is no way of changing the IDF, but the configuration of IDF can be changed through the Arduino's component, which is not possible when using IDE, any kind of that Arduino or Platform I/O.
Following question. Are there any things to do if we use ULP?
No, actually, ULP, if you think about it, IDF can build it. If you use, there are two ways to use ULP. One way is using the macros from IDF. Those macros are used in the Arduino. There are examples with in Arduino with those macros, so you can use and do the same. UOP in the macros will be kind of creating space in the memory and the RTC memory where you're gonna put your program, let's say, and your opcodes will be there to be executed by the UOP. If you use IDF itself for building UOP, you're gonna have maybe some assembly, let's say, kind of code, and IDF has already everything in place to build it and link it as a blob, let's say binary blob, to be again copied to the RTC memory space and executed by UOP.
I have one more question for you. The last one. What's the proper method to add Arduino library? Now I have to modify CMake list inside Arduino component.
Yeah, well, there are two ways to do that. One way is using, both ways are using make list, CMake list. So if you want to do it maybe simple, you can go to your application folder, which is the main folder. There you just edit the CMake for the application, not from the Arduino library itself. You can add, for instance, include directories and include source files, create your library folder inside your main application folder, and then add that library folder in your CMake inside your application CMake, and that will be included in the process of compilation, and it can have everything just copy all the libraries from that you use in Arduino, the versions you want to, directly to this folder inside the folder for the application itself, and they will be compiled and also included. There are also some questions sometimes about how do I do, for instance, to use PSRAM. So because the IDE, it will set up a symbol, it will define a symbol for all the compiling process. So another way to do that, again, is in the CMake file for the application. You can define that any additional defines there too, it is possible. In particular, for if you want to modify the way, for instance, for PSRAM, you might need to add that actually to the CMake in the Arduino library itself and the component. So you define, for instance, that the chip has PSRAM there. That will be the same that the IDE will do for the building process. So in that particular case, you need to do it most probably in the Arduino library component folder. But for libraries in the Arduino, you can do it both in the Arduino component CMake, or if you want to, in your application side too. In case you need to use the CMake list and modify it, there is no other way, or this is maybe the best way actually to do it.
Thank you, Rodrigo. So I think our time is over. I just see some new questions, of course, in the chat. So I will just gladly ask you to go to the chat and answer them by written form. And I'm sending the greetings to Brazil, and see you.
Thank you. Thank you very much. See you. Bye-bye.
And for all of you viewers, I will just recommend to stay in the streaming, because we are now in front of a very interesting talk from Adafruit, and it's going to be about CircuitPython